Hello students, welcome back to my channel, and today I am going to discuss about class 12's vector algebra chapter. And today our topic will be some properties of scalar product or dot product and its some of the applications. So students, property number 1 is distributive law. Distributive law of what? Distributive law of dot product over addition. Normal distributive law that you already actually did it for real numbers. The same thing here, or rational numbers. This is only vector and its dot product. That means it's like this. Suppose A, B, C are three vectors. So A dot B plus C will be equals to A dot B plus B dot C. Okay. B dot C. A dot B plus C is equals to A dot B plus B dot C. And this is the first property. Second property is, suppose A and B are two vectors. Lambda is a scalar. Then lambda into A dot B vector, like this. Lambda into the dot product of two vectors is equals to, lambda can be shifted anywhere because this is dot product's property. So it can be written like lambda A vector dot B vector, or it can be written like A vector dot lambda B vector. So the main thing is that lambda is being multiplied to any one of the vector, not both the vectors. Okay, so this is not distributive law of scalar multiplication and all. So this is like this. So this is property number 1 and property number 2. Now property number 1's application is a big result, you can see. So I'm going to do that. Let A vector is equals to A1I plus A2j plus A3k. A2. B vector equals to B1I plus B2j plus B3k. We will find out A dot B's value with first property, not by the definition. Because suppose when we will be using this first property, when we will not have the given angle between this. Okay, if we don't have the angle, then we can't apply this formula, right? Mod A mod B cos theta. So for cos theta we need to get theta, but suppose theta is not given, then we need to follow this first property. So how we will be writing a simple multiplication? Just the way of writing is different. Dot B1I plus B2j plus B3k vector. So we will first fix up the first term. This first term to be get the dot product with this. Second term to get the dot product with this. Third term to get the dot product with this. So A1I dot B1I plus B2j, like this. I am not writing everything because it will be very lengthy. I am telling it. So this dot this, the first one, because this dot the whole one is the distributive law just we have done. We can individualize it, dot product individualized. So A1I, I'm writing over here, A1I plus, sorry, dot B1I. Just in the second property, we told that scalar part can be taken outside. That means A1 B1 is like this. A1 B1 into I dot I. I dot I, already in the previous video, you can check the link in the description box. In the previous video, we have found it is as 1. That means finally we are getting A1 B1 as its result. That means the first one is A1 B1. Okay, this one is A1 B1. Coming to the second one, means first to its second, A1I plus B2J. In the same way, A1 and B2, A1 B2 will be coming out like this, and this will be J. It's A1 B2, this is J, right? I dot J equals to 0. Already we have done, because these two are perpendicular vectors. So perpendicular vectors will get the dot product as 0. That means this is into 0. So ultimately it is 0, so it's vanishing. Then similarly A1 B3 into I dot K. I dot K is also 0, so that's also vanishing. So the main point is only I dot I term, J dot J term and K dot K term will be here finally. Rest all terms are having perpendicular vectors dot product. That means they will be 0. So we have got A1 B1. Similarly we will get A2 B2 because this is J dot J. A2 B2 and this one is A3 B3. Okay, rest all terms. There are 3 into 3. That means there are 9 terms. Among those 9 terms, 6 terms are coming with perpendicular vectors dot product. That's why they are getting 0 value. Rest of the terms, that is A1 B1 plus A2 B2 plus A3 B3, is having the multiplier as 1, and this already I have just erased. First one is 1, so this is the final calculation. That means I'm writing it again because this is also a formula of dot product of two vectors. A dot B equals to A1 B1 plus A2 B2 plus A3 B3. Okay, so you can go with this one also. Actually maximum times you will be using this one very frequently while doing the applications. Now coming to dot products application, and you can say dot products geometric, not geometric, I will be saying it its application, its representation, and physical representation. Physical representation is actually projection, finding projection of something, projection of a vector. That is the main application of dot product, finding projection of something. Okay, so projection of a vector is our next topic. Projection of a vector. For this, I am drawing a sketch like this. This one, suppose A, this is B, this is the vector L or the line L, you can say. Okay. Now, I am not giving this one. This is like this. This is theta. This angle is theta. That means AB is a vector, is making the angle theta with a line. We will be finding projection of the vector AB on this line L. Okay, this is our task. So projection means we need to draw a perpendicular on the line. I'm giving the name as C. So from A to C like this, and you can see the right triangle, right? What will be AC's magnitude? You forget about all vectors, sign and all. Think about that AB, BC and AC, three sides of a right triangle, and theta is this angle. Then what it will be? Don't you think that AC is AB cos theta? Now what is AB? AB means mod of AB vector, and AC means, I'm writing AC means AC here. So AC is the projection of the vector AB on the line L when theta is this angle, that is 0 less than theta less than 90 degree. So there are four other options, like drawing the line L, suppose like this. This is theta. Okay, this is theta. We will always take the theta anti-clockwise. Okay, that's why this is theta. This is B. This is A. Again we will be drawing it. This is C. This side AC will be like this. Okay, and this one is theta. So this will be 180 degree minus theta. That means actually pi minus theta, right? So pi minus theta means we will be getting AC is equals to AB cos of pi minus theta. Cos of pi minus theta, this one will be AB means minus cos theta. This will be minus AB cos theta. Now minus AB cos theta, that means this side. Okay. So the plus and minus sign will give you the direction of it. So I'm just giving it modulus. Okay. Then there is another one. Think about the line like this. This is A, this is B. Okay, this will be C, AC like this. Theta is this one. Then also I'll be getting it's mod AB cos theta. Plus minus sign I'm not taking because magnitude will not have its plus minus. Magnitude always will be the absolute part. Okay. Plus minus sign will be important for determining the direction of the vector, whether this is towards that or towards this. Okay, simple. Then fourth figure is like this. This is A, this is suppose B, so this is C, this is theta is this one. This time theta is pi, this part is pi minus theta, this angle is pi minus theta. So we will be again getting, if you are calculating it, you will be getting this, the magnitude, pure magnitude, you will be getting this one, mod AB cos theta. That means in all four cases, in this case 0 is more than 180 degree, less than 270. Here 0 is more than 270, less than 360 degree. So in all four cases, finally we can say that the projection of the vector AB, projection of the vector AB is mod AB cos theta. Okay, and its direction, projection of AB vector is mod AB cos theta, and its direction will be defined by its sign, either positive or negative. Now this is the way for finding the projection. Okay, now I'm just drawing the figure again. First figure I'm drawing, this is A, so directed line is A, this is A, this is B, this is C, and this one is theta. Obviously AC is mod AB vector cos theta. This AC vector, its name particularly we call it as P vector. P vector represents the projection vector whose magnitude is mod AB cos theta. Projection vector is P vector whose magnitude small p is equals to mod AB vector cos theta, and small p is called the projection, small p vector is called the projection vector. Now there are some observations depending on this figure or the topic projection of a vector. There are some observations. Number one, P is a vector, that means this side there is a unit vector. Let it be P cap. Okay. Now this side's unit vector is P cap. So A dot P cap, normal dot product's definition, it will be mod A dot mod, not dot, into mod P cap cos theta, because theta is the angle between unit vector and that vector. This is I'm giving as name A vector. Okay, I'm not writing AB vector always. So A vector dot P cap is equals to mod A into mod P cap into cos theta. Mod P cap always will be 1. Why? Because it's unit vector. That means we can write down mod A vector cos theta. Look, ultimately this one or not, because AB, suppose I'm giving A, so it's mod A vector cos theta. So we can say, in other words, that A dot P cap is the projection. Okay, A dot P cap, what we will write? A dot P cap is the projection of A vector on P vector. Sorry, not on, sorry, A vector on a line, okay, L, or P vector. Okay, but it will be more precise. Then second observation. Second observation is that projection of A vector, just second observation is application of first observation. Projection of A vector on B vector equals to A dot B cap. B cap is the unit vector along B vector. That means A vector dot B cap is actually B vector divided by modulus of B vector. Modulus of B vector is a scalar, can be taken as lambda, am, k, whatever you can choose. So it can be ultimately written like this, mod B vector. So you can say projection of A vector on B vector is equals to A dot B divided by B. Divided by B means mod B vector. Okay, this is second observation. Third observation I am writing over here. Third observation, if theta equals to 0 or theta equals to pi, in both the cases, suppose theta equals to 0, that means AB is coming like this on AC. So it is quite obvious that projection will be AB, right? Because it is going along the given line, so projection will be AB. And when we are getting pi means 180 degree, that means this side. So I need to change the figure a little bit, otherwise it will not be proper to get the idea. First one, we have got AB this side, A and B, that means the projection is AB itself, no problem with that. And if this side AB is not here, suppose B is here, then this one is pi, angle is pi, because L directed line is this side, its angle is pi, then AB vector will be negative of L, means will take the opposite direction of directed line L. Okay, so we have got this. Projection is AB again, projection is always AB. Now number 4. For number 4 again I have to draw something. Number 4 is, suppose this is perpendicular, A, B. Perpendicular line, you think a projection means actually shadow, nothing else, actually shadow. So you think about that the sun is exactly above AB, then its shadow will be nothing. Okay, so projection is 0. So for number 4, for theta equals to pi by 2, projection is 0. And for theta equals to 3 pi by 2, that means suppose like this, A and this is B, then also the projection is 0. Okay, here also the projection will be 0. So these 4 are the observations depending or based on projection of a vector, which is direct application of dot product or scalar product of two vectors. Now depending on these dot products concept, you will have your exercise in your NCERT book, which is exercise 10.3. And I think now exercise 10.3 all questions are like very easy if you are practicing it. Very simple. There is nothing such difficulty here. So let's pray that you can do it, and let's hope for the best. So this is all about today's session, students. I hope you have understood it and hope that you can apply it in the exercise questions also. So in the next video we will meet again with any other new topic. Till then, have a good day.